You've probably heard the term smart city thrown around a lot, right? But what does that actually mean? Well, it's not just about fancy apps and super fast internet on your phone. See, there's this hidden network, almost like a city's nervous system, that's quietly changing everything about how our urban spaces function. And to understand it, we've got to start with one big, fundamental question.
So if you want to make a city genuinely smart, you need data. And I mean rivers of data. From everything. But just stop and think about that for a second. How on earth do you connect millions of tiny little sensors scattered all over the place, across miles and miles of concrete, steel, and even subways? It's a huge challenge, right?
And that right there, that is the smart city's biggest dilemma. It boils down to a massive connectivity problem. A problem that, as you'll see, our everyday tech, the stuff we use on our phones and laptops, it just wasn't designed to handle.
I mean, the vision itself is incredible. Just imagine it. Sensors that are checking air quality block by block. Others that can spot a water leak the second it happens. Some that are tracking traffic flow to ease congestion, or even just checking if a trash can is full. All this data, it could create cities that save a ton of energy, conserve precious resources, and just, work better for all of us. So, what's the holdup? Why isn't this already happening everywhere?
Well, it's because the tech we're all familiar with, Wi-Fi and your cellular connection like 4G or 5G, they're built for one thing, speed. They're for streaming movies, for video calls, for downloading huge files. They are power-hungry beasts, and that means they burn through batteries and cost a fortune to deploy across an entire city. But a smart city sensor? It's the total opposite. It just needs to send a tiny little whisper of data, like, hey, this parking spot is open. But it has to do it super cheaply, over massive distances, and it has to last for years on a tiny battery. It's a complete and total mismatch.
So, what do you do when the tools you have just aren't right for the job? Well, you invent a new one. And that is exactly what happened here. The solution is a technology designed for this very specific problem, and its name is LoRaWAN.
Yeah, the name pretty much gives the game away, right? Long-range, wide area network. It's a wireless protocol that was literally built from the ground up with one mission and one mission only: to connect small, low-power devices to the internet across huge, huge distances. And how it pulls this off? Well, that's what makes it so cool.
Okay, first off, let's talk about the range. It is absolutely staggering. We're talking about a single gateway being able to pick up a signal from up to 20 kilometers. That's about 12 miles away. Just think about that. Your home Wi-Fi can barely make it to the backyard.
Next up is power consumption. It is ridiculously low. This means you can put a sensor out in the field and just leave it. It can run on a single, small battery for years. It's the definition of set it and forget it.
And finally, let's talk scalability. Just one of those long-range gateways can listen to messages from thousands of individual devices. Thousands! Now that is how you cover an entire city without completely breaking the bank. It's the secret sauce.
Okay, but this isn't some science fair project or a futuristic concept. It's happening right now. Cities all over the world are already using LoRaWAN to get smarter. So let's take a quick trip around the globe to see exactly how it's being put to work.
First up, we're heading to Malaysia. They're tackling one of the biggest, most obvious energy hogs in any city: streetlights.
So in a place called the Selangor Cyber Valley, they've set up a LoRaWAN network that gives them remote control over their streetlights. So think about it. If a street is empty in the middle of the night, they can dim the lights. But as a car or person approaches, they brighten back up. It's simple, but it dramatically cuts their energy use and, of course, shrinks the whole city's carbon footprint.
All right, next stop on our tour, let's hop over to Cyprus. Here, they're using this tech to manage what is arguably their most precious resource: water.
The city of Paphos went big. They've rolled out over 30,000 smart water meters. Each one of these uses LoRaWAN to phone home, and they can detect even the tiniest leaks or weird backflow issues pretty much instantly. The result? They save a massive amount of water, and people get billed accurately for what they actually use. No more guesswork.
Okay, for our last example, we're off to Sweden. And I love this one because they're solving a problem that is surprisingly complicated in a big city: collecting the trash.
So, in the city of Södertälje, they've put simple sensors inside their public waste bins. These little sensors just report back one thing: hey, I'm full.
This means the garbage trucks don't have to drive the same old, inefficient routes every single day. Instead, they get a custom route, sending them only to the bins that actually need to be emptied. It saves fuel, it saves time, and it cuts down on those noisy trucks waking you up at 6 a.m. when the bin on your corner was empty anyway.
So it sounds pretty amazing, I know. But it's really important to remember that, like any piece of tech, LoRaWAN isn't a magic wand you can just wave at every problem. So to really get it, we need a little reality check. It is all about using the right tool for the right job.
Here's the fundamental trade-off, plain and simple. LoRaWAN is absolutely perfect for sending tiny bits of information from things that are either standing still or moving very slowly. You know, things like water meters, soil sensors, that kind of stuff. It's a champion for those long-term, low-maintenance jobs. But because it's so focused on long range and super long battery life, you would never use it for, say, streaming a high-def video or trying to track a speeding bus in real time. And let me be super clear, this is not, I repeat, not a replacement for your home Wi-Fi.
And yeah, that performance can change depending on the environment. So the packet delivery rate, that's just a fancy way of saying how many messages actually get through, is around 95% in perfect, ideal lab conditions. But you take it into a messy, real-world city with tall buildings and all sorts of other signals flying around, and a study found that rate can drop. It's still really good, but it just goes to show you that building one of these networks isn't just plug and play. You have to plan it out carefully.
So, let's get into the fine print, the key limitations. First, the data rate is tiny. Think text messages, not video files. Second, the response time, what engineers call latency, can be a few seconds. It's not instantaneous. Third, to stop everyone from talking at once and jamming the airwaves, there are rules, duty cycle limits, that say how often a device is even allowed to transmit. And finally, the physical stuff gets in the way. Thick concrete walls, a whole forest of trees, that can definitely affect the signal.
But look, these aren't deal breakers. They're just the next set of puzzles for engineers to solve. They see a limitation, and they see an opportunity to innovate. So that begs the question, what's next? Where's all of this heading for our cities?
This is where it gets really, really cool. The future is all about teamwork, combining the best of different technologies. So imagine using the massive speed of 5G as the superhighway that collects all the data from these low-power LoRaWAN networks. Or using AI and machine learning to predict where signals might get blocked, and then intelligently reroute the data around the problem. People are even exploring things like blockchain to make the data totally secure and tamper-proof, and developing smarter ways for signals to literally hop from one device to another to get around buildings.
So in the end, LoRaWAN is a crucial part of that invisible nervous system we talked about, the one that's making our cities smarter, one tiny little piece of data at a time. It's just amazing proof that sometimes the biggest revolutions are powered by the smallest, quietest, and most overlooked technologies. Which leaves us with just one final question for you to think about. If you had this power, if you could connect anything, what part of your city would you connect first?